So I'd like to look at a regression analysis and figure out the different parts of the regression equation and the correlation and make a residual plot and do some things with it. So I have some data from the 2011 football season. This is the SEC conference in 2011, the schools, the number of points they averaged per game, and the number of wins they had per game. The first thing I asked to do is to draw a scatter plot of the data. Now I'll move kind of quickly on some of this, so if you need to press pause, as always, press pause. I've typed this data into my calculator into L1 and L2, and I'm going to choose to make the points per game the explanatory variable. The horizontal axis will be the points per game. So when I make a scatter plot, I go to second stat plot, turn it on. This is a scatter plot of L1 and L2, and to graph it I press zoom 9. That's zoom stat, and I get this graph right here. Wrong thing. Drag it onto this. And it says, what do I notice? I should also notice that I should put some more information on here. Football 2011. Maybe as a title, and then I can put points per game here, wins here, and some sort of scale which is obtained when I press window. I can see that the x-axis goes from 13 to 38, so this is probably 13 to 38, and the y-axis goes from 0 to 14. 0 to 14, or 0 to 15 really. So it's going to be 0 to 15. So I have some sort of scale. But as far as the things that I notice, what I want to notice are the strength, the form, and the direction of this, and I'd like to notice it in context. So what I have here is I notice that there's a strong relationship. It's positive. It appears to be something like this. And so to describe that, I'm going to say that I believe there is a strong, positive, linear relationship. And now I'll put it in context between points per game and number of wins. Now some may say, should I include the fact that this was the SEC? It's certainly not wrong to do so, but there's no ambiguity because I'm not talking about any other conference, so it would be okay to leave that part off. Number 2 says find the slope, and 3 says find the y-intercept. So to do that, I'm going to press stat, calc, and I'm going to go down here to number 8. That's the one I choose to use. Stat calc number 8. And I set it up where my x list and y list are L1 and L2. And I'm going to store the regression equation into y1. So I press vars, yvars, function, y1. And now when I hit calculate, it calculates that information for me. Now as it turns out, it didn't show me r and r squared. I'm going to go ahead and do that in just a minute. Yours may already show it to you, but I don't need that to answer questions 2, 3, and 4. So the slope here is the number in front of the x, that's the b. And the y-intercept is the a. And then of course it says to interpret both of those in context. Well, the slope says for each additional x, I expect that y will change by that b amount. So for each additional point per game, I expect, that's the hat part, I expect to see an increase because the slope is positive, of 0.4372 wins. Now the y-intercept says if x is 0, I predict y to be this amount. So if I score 0 points per game, which is obviously terrible, I expect to see negative 3.75 wins. Now obviously that's impossible. You can't have that number of wins. But I remember that when I looked at my graph, it didn't go all the way to 0. So this line does end up going south of the horizontal axis. And the fact that it's unreasonable doesn't mean that it isn't still the y-intercept. And now report the LSRL. So the LSRL is y hat, don't forget the hat, negative 3.75 plus 0.4372x, where x, and then this is the defining the terms part, x is the points per game, and y is number of wins. Okay, so now I need the correlation and the coefficient of determination. So I need my calculator to show me r and r squared. So to get that to work, I need to turn my diagnostics on. There's a couple of ways to do this, but one way that's universal on all these TIs, regardless of exactly which edition, is to press second catalog, go down to the D's, which you can scroll to, or you can press D, and then go to diagnostic on, press enter and press enter again. Now I have to recalculate the regression to have it show up. So I'm going to go stat calc number 8. I don't need to restore the regression equation because it's in my y1. So I can press calculate and it works and I get this information. The correlation coefficient is r. The coefficient of determination is r squared. Don't write r and r squared for both of them because that just tells me that you don't know which one's correlation and which one's the coefficient of determination. So the correlation is 0.9359 and the coefficient of determination is 0.8759. Now the correlation says if the data are linear, this is a measure of how close to the line those points are. It's very close to 1, so it indicates that the points are really close to a straight line. The fact that it's positive tells me the slope is positive, just like I saw when I looked at the slope. So I'm going to say there is a strong, positive, linear relationship. This is very similar to what I did at the very beginning between points per game and wins. Now this is not a shock. When you score more points, you tend to win more games. It would be nice, I didn't need to do it for this problem, but if I had had any outliers, I would talk about that. If I had a point, say for example right here, I would talk about how interesting it is that they won a lot of games without scoring many points. So maybe the defense was involved. We're not saying that there's a cause and effect relationship. Sometimes there is. Maybe it's partly cause and effect. Maybe it's tangled up with some other things. But this is how I would interpret R. Now R squared is a percentage. And this says that 87.59% of the change in Y is explained by the least squared regression line, which you can abbreviate, of Y on X. You should memorize that sentence. And then what I do is I go back and I change my X and Y to the context of the problem, because you always want to put these in context of the problem. So Y was wins. Y is wins. And X is points per game. Now we're impressed with the linear relationship here, but now I want to see if the relationship really is linear. So for number 7, it says draw a residual plot, and what does it tell you? Well, what I want to look for in my residual plot is a pattern. And so I'm going to make a stat plot a scatter plot, just like before, but instead of L1 and L2, it's going to be L1 and resid. So to get to my residuals, I press second list, and I scroll down till I get to resid. Now you may have different things on here than I do, but if you've done linear regression, like we did on parts 2 through 6, then your calculator calculated the residuals and stored them in this list. So there's the resids. And now when I press zoom 9, I get this graph here. You see right up here just the very tail of this y equals equation. If that bothers you, I could go to the equal sign and press enter, and now you notice that equal is not highlighted, and so now that part will be gone, or I could simply ignore it. Now what I'm looking for here is a pattern, and I'd still like you to label this residual plot. Whoop, don't twist it. So I know what it is. And this X list was points per game, and this Y list was resids. Okay. A scale is a good idea as well. I can press window and check that out. But what I'm really looking for is a pattern. Is there a pattern in my residuals? No, not here. No pattern. Since there's no pattern, the method that I used, the linear regression, is a good idea. So I do not see a pattern. So the idea of linear regression, since that's what I did, is a good one. Or another way to put it is, it's appropriate to do linear regression because I don't see a pattern in the residual plot. Now number 8, it says Texas A&M scored an average of 39.1 points per game in 2011. A&M wasn't in the Southeast Conference at that point, and the question is, how does their number line up with these numbers from the SEC? So let's plug in a 39.1 into the equation and see what the equation predicts the Aggies' number of wins would be. So on my home screen, I'm going to press vars, yvars, function, y1, and I'm going to plug in 39.1. This is just like plugging in 39.1 into this equation that I did on number 4. And when I do that, chicka chicka whir whir gives me this. The equation predicts 13.34 wins. Go ahead and include the decimal points there. That's fine, even though you can't get part of a win. So here's my prediction. The LSRL predicts the Ags would win 13.34 games. Now, as it turned out, the LSU had 13 wins that year and played the national championship against Alabama, who only had 11 wins. So clearly this equation is not working great for the Aggies. You could speculate why. It's irrelevant for the sake of doing this problem. You don't have to understand football or the SEC or anything, so don't spend a lot of time on that part. Now it says, as it turns out, the Aggies won 7 games. Oh, let me back up. How close do you think it will be? Well, my R and R squared were pretty good. I think the relationship is linear. The trick is, I'm not real sure if the schedule that the Aggies played in aligns itself with the schedule that the SEC had. If you appealed to the fact that R and R squared were pretty good, I'd like that. If you appealed to the fact that the residual plot showed no pattern, so a linear regression was appropriate, I would like that as well. So now I want to find the residual, and so a residual is y minus y hat, or the actual minus the predicted. So for this case, it's 7 minus 13.34. Now, if you're one who messes up the mental math, don't risk it. Grab the calculator. 7 minus 13.34. Just do it that way. And we see that my residual is negative 6.34. The negative is important because that means that the actual amount was less than the predicted amount, and that's important. Finally, on number 9, it says find the value of S, the standard deviation of the residuals, and tell me what that means. So here's the formula. They gave me the formula, and this is not as hard as it looks. You might need to pause the video as you work through it on your own, but my residuals are calculated for me. I'm going to go ahead and make a copy of them in L3. So to do that, go up and highlight L3, press second list, go to the resids, hit enter. The residuals are going to copy into here. The sum of these numbers would be 0. Now I'm going to square the residuals. That's the next part right here. So on my home screen, I'm going to go L3, squared. There's the square of them. Next thing I do is divide by n minus 2. That's the number of teams minus 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to divide the sum by 10. So I'm going to sum up, second list, math, sum of L4 divided by 10. Then I need to take the square root. So square root that answer. That value right there is S. If we needed to show some work, we could include these lists right here if necessary. But really what I'm interested in is this number and what it means. And what it means is the typical amount that I'm wrong, the standard difference is 1.235. So the typical error in predicting the wins is about 1.235 wins. It's a measure in units of the problem, in units of the y, how wrong I am typically. And in this case, it's 1.235 wins is how wrong I am. So hopefully that helped going through all the different components to finding linear regression and analyzing your work from there.